Activity 1, a walkthrough of Activity 1 in Chapter 9. The goal is to, while we allow a display object, a shape of some sort, to be dragged by the user, so I've got a star in this example, lots of times we don't want it to go off screen. If you play around with these, what you'll find is you can drag stuff off screen and drop it, and then you can't get it back. So there are circumstances in which you'd want to sort of fence in a display object. So the example in Chapter 9 walks you through how to use a function that will define that fence, how to visually see the fence, and then when dragging, how to keep track of whether the object has hit the fence or not. So that's what I want to walk through really quickly. So there's actually a function built into Drawn2Code to get that box for you. So let's just start out with an empty design, and let's add our polygon. It does not have to be a star. It could be a star. It could be your favorite shape if it's not a star. And then we want to get the function. Okay, it's the second function down. Get boundary box. In and of itself, the function doesn't do anything. Like all functions, you have to call it. You have to use it in some way. So the chapter steps you through the syntax for calling it. And it's pretty straightforward. We'll just put that in a snippet. So heading back to the design, we'll create a new snippet, and then in the snippet we're going to call the function. So we're going to say object1, which is our polygon, dot bounds equals get boundary box object1. So that might seem a little bit circular, but what we're doing is we're adding a new attribute to object1 called bounds. I forgot the S. It doesn't matter. It's whatever you want to call it. If you wanted to call it fence, you could call it fence. And we're setting it equal to the result of the return of get boundary box for object1. So that defines four characteristics, four attributes for the bounds. That is the right, the left, the bottom, and the top. And we can use those if we want to actually draw and visually see what the fence is. Slide 10 in Object 9 steps you through that. Since we're using calculations to derive the coordinates for the fence, we can't use for the rectangle, we can't just use a simple rectangular display object. We've got to use a snippet, and if you use a snippet and paste this in, it should work just fine. So if you want to do that, we can copy that and head back to the design. We'll want to put it in a snippet. We could add on to the existing snippet that we have. This should work because object1 is it's already got the call in there too. So I'm setting up a new rectangle called object7. I think in the later examples I call it fence. It doesn't really matter. It's a new rectangle. I am using display constants cx and cy here, so we've got to make that work, we've got to call display constants and put those in the stack as well. So this snippet we're working on is, let's call it define and show the fence. And that's exactly what it does. It defines the fence called bounds, and then it displays it as a rectangle. Sets the fill color of the rectangle to not visible, and sets the stroke color to red and the stroke width to 1. So we should be able to save it and test it. I'm going to call this see the fence, and if we run it, we should see the star and the fence, unless I've done something wrong. In which case we'll get to go through the code and see what I did wrong. There we go. Okay, so the star and the fence is step 1 of this activity. And we can't drag the star. We haven't hooked up the touch listener to it. We don't have the code in there to do the dragging. So all we've got is a polygon that can't be dragged and its associated fence that would keep it on screen. So next step is to add the touch listener to our our polygon. In my case, it's a star. You might have used a star, you might not have, but the key thing is you don't want tap, you want touch. That now allows the star to be touched and dragged. And I'll just show you that you can move it past the fence because we haven't added the codes yet that will enforce the fence. So we can go off screen, which is what we want to try to stop. Okay, so let's switch back to the keynote, enforcing the fence. Okay, so we want to add this code in this bottom chunk here to the touch handler. So first off, let's find the touch handler in our stack. Let me zoom into our stack. Okay, so the touch handler is right here. It's object 5. The snippet is object 6. Default touch drag support. So let's pop that out and have a look at it. The code we want to adjust is right here in the moved phase. So instead of just blindly moving the polygon, we want to test and see whether this proposed X and Y location is inside the fence or not. So instead of these current lines 40 and 41, just set the target's X and the target's Y value blindly. So that's the star in my case. So we don't want to do that. We want to instead double check things first. So if we go back to the keynote, this code should work. So I'm going to copy it and paste it, and then I'll talk about it and test it. So I want to remove the current kind of simple code and replace it with this version, which instead uses the same exact math there. It calculates essentially a proposed X and Y value, and then it uses the bounds to check and see whether or not the X value is valid, and then separately whether the Y value is valid, because either or both could be bad. So it checks X first. It uses these bounds values. So it says, is the proposed X value, let me zoom in a little bit, sorry. Is that proposed X value, I'm looking at line 44 here, is this proposed X value that we calculated up here, is it to the right of the left bounds and to the left of the right bounds? If so, then it's okay, it's inside the fence. And then I do the same thing with the Y value. Is the Y value below the top bounds? Is the Y value greater than that? Because we count positively down. And then is the Y less than the bottom bound? So does it not exceed the bottom of the fence? If so, then this new proposed Y value is good, and we can do the assignment. So let's save it and have a look at what this does for the behavior of the dragging. So I can still drag it, which is great, but now I can't get it past the fence. I can try, but that fence is now being enforced. You will notice if you drag it really quickly that you can kind of interrupt the fence code or cause the fence to trigger early or sometimes slightly late, just because it's not keeping up with how quickly the drag is occurring pixel by pixel. But for reasonable speeds, dragging the fence approach normally works really well. That is activity 1. That's a walkthrough of activity 1, chapter 9, dragging and collisions, how to fence in a polygon that's being dragged.